Okay, what is happening, my little babies, from the 403 to the HAZ? Mr. Nelson here. We are talking about combinatorics, and combinatorics is just an investigation of the different ways we can arrange objects, ideas, same thing. And in the last video, kind of our introductory video, we talked about the notion of factorial, right? So when I'm trying to arrange 5 objects, see all the different ways I can arrange 5 different objects, right? So there's no repeats. So like, you know, A, B, C, D, E, okay? Figuring out how all the ways I can arrange these is basically just taking the amount of unique objects and doing factorial. So I have 5 objects, I'm trying to figure out how many ways I can arrange them. I can do that 5 different ways. This one I have 4 to choose from, 3 left to choose from, 2 left to choose 1. 5 factorial equals 5 times 4 times 3 times 2 times 1. Now, the first thing we're going to look at is what happens when we have repetitions, okay? So what would happen if instead of A, B, C, D, E, I had A, B, C, C, D. And I said, how many unique, whereas C is the same as C. These are, we can't tell the difference between this C and that C, okay? How many unique ways can we arrange those 5 letters? And in this case, it's the same thing. It's going to be 5 times 4 times 3 times 2 times 1. However, at the end, we need to divide by the amount of repeated objects factorial. So in this case, I have 2 repeated C's, so this becomes 5 factorial divided by 2 factorial. And then that works out to 5 times 4 times 3 times 2 times 1 divided by 2 times 1. And if I'm smart, I realize, oh, this cancels with that cancels with that, and then my answer is really just 5 times 4 times 3, 60 ways. Versus up here, it was 5 times 4, which is 20, 60, 120. So as soon as I add 2 of the same object, I can only arrange them half as many unique ways. So let's do one slightly more difficult one, and then we're going to move on to restrictions, which is a little more involved. It takes a little bit more thinking, I think. Repetitions is really just knowing the formula. So what if I had the word ogopogo? I love mysticism. I love the idea of things being out there which we cannot explain with science, so let's talk about the ogopogo. How many different ways can I arrange the letters in ogopogo to get unique combinations? Well, how many letters do I have? 1, 2, 3, 4, 5, 6, 7. So that's going to be 7 factorial, but then I have to divide it by my repeated object. So I have 1, 2, 3, 4 O's. So I'm going to have 4 factorial, and then I have 1, 2 G's times 2 factorial. Okay? And that will give me the amount of combinations of those unique combinations of these letters that I can get, orders. And if I were to write this one out, I get 7 times 6 times 5 times 4 times 3 times 2 times 1. Divided by 4 times 3 times 2 times 1 times 2 times 1. This cancels with that. 3 cancels with 3, 4 cancels with 4, and then I get 7 times 6 times 5 divided by 2 times 1. And I do the math and I come up with 7 times 6 times 5 divided by 2. I get 105 unique combinations of these letters. Unique. Okay? So that is repetitions. There's not much more to tell you. I think you'll be able to figure that out. Okay? So what happens now if we get restrictions? So what's under restriction? Well, let's go back to our A, B, C, D, E. Okay? And restrictions they require us to start thinking a little bit, right? And it's always good to draw the stuff out. So if I said how many different ways can you arrange these letters, you'd say 5 factorial. 1, 2, 3, 4, 5, 5 factorial. Now what if I said, how many ways can you arrange these letters so that C is always in the middle. Okay, so basically we're saying this is a restriction. C is always right here. How many ways can you arrange these letters? Well, now we can't really do factorial now because it's getting messed up by this. So what we do is we just have to start thinking about it. Well, how many choices do I have for the first slot? 4. How many choices do I have for my second slot? 3. C, that's always, it's only one choice, so that's just a 1, or C. I can change that with 1, it's 1, but I'm just going to leave the C there because 1's not going to change the math. How many options do I have for this slot? 2. And how many options for this slot? 1. Now you might be asking, well, why do you always start on this stage? Why do you always start on this on the left and move your way right? Well, I don't have to. Because if I'm multiplying all of these anyways, if I started on this chair, well, there's 4 choices for this chair. And then if I came over here next, there's 3 choices there, 2 choices here, 1 choice there. And if I multiplied it out, it's the same as if I went 4, 3, 2, 1. And so I get 4 times 3 times 1 times 2 times 1, 12, 24. 24 different ways when I have the restriction that C is in the middle. Okay? What if I had a different restriction? What if I had the restriction that B and E must be on the ends? So this is either B or E, and then this is either B or E. Well, how would that one be done? Well, what are your choices for the ends here? Let's say I start on this one. Well, I have 2 choices, B or E. And if I have 2 choices here, by selecting 1, I left with 1 choice on the other end. And I could have done it the other way. I could have done 2 choices here, leaves me with 1 choice here. Okay? So there we've got 2 out of the 5. And then the rest, doesn't matter where I start, I have 3 choices here now, I have 2 choices here, and I have 1 choice here. And therefore, my answer is 2 times 1 times 3 times 2 times 1, or times 3 factorial. And if I do that, I get 2 times 1, and it doesn't matter which way I do the multiplication, I'm just trying to show you. 2 times 1 times 3 times 2 times 1, 2 times 3 is 6, times 2 is 12. 12 ways when I have an additional restriction, which makes sense. I should have less ways of ordering them when I have more restrictions. The more restrictions, the less amount of ways I can achieve something. Okay. What if I said, how many ways can you arrange these letters if D and E have to always be beside each other? Okay? D and E now have to always be beside each other. So what happens in this case? Now this is where you start to kind of learn how different scenarios play out. And in this scenario, when you have a restriction where 2 things have to be together all the time, well then essentially those 2 things become one object with 2 factorial possibilities. And then you can just treat this as, so if you're treating this as an object, then your solution is 4 factorial, because I have 1, 2, 3, 4 objects, but then I have 2 ways of ordering the D and the E, right? So pretty much one option is A, B, C, D, E, and then another unique one would be A, B, C, E, D. So 4 factorial times 2 factorial. That's what happens when you have objects that need to be beside each other. If I said that the C and the D and the E had to always wind up grouped together in one group where the C, the D, and the E are beside each other, well now there's 3 factorial ways of ordering these, but then if these are going to be treated as one object, then I have 1, 2, 3 factorial, so it's 3 factorial times 3 factorial. Right? Because I'm ordering these objects, but then I'm ordering these ones inside. Hi, Rachel. Oh, did you find something for me?
This year, I told my boss, he said everybody's supposed to sign it.
Everybody's supposed to sign it?
Yeah, it goes back to HR.
Okay, thank you. Appreciate it. Thank you for looking out for me. Thank
He
you.
said not even just the custodians, it's everybody.
Okay, I should read my email, shouldn't
Yeah.
I? Okay, thanks, Rachel. Okay, so, and then there's one in the textbook. Actually, I'm not even going to do that one just yet. We'll get to it. Okay, so that's great question. So what if I had A, B, C, and D, and E? This is a thinking problem. And I said, okay, A and B can never be beside each other. How many ways can you sort these out? In this case, we have to figure out all the different ways that A and B can never be beside each other. Okay? So I can have A space B space space, where A and B are, you can interchange them. I'm just trying to figure out all the ways. I could have A space space B space, where A and B can interchange. I can have A space 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 B on the ends. And then I can have space A space B space. I can have space A space space B. And then I can have space space A space B. And assuming that I can interchange A and B together, there's 6 different ways. So there's 6 ways of not having A and B together, and then I have to multiply that by 2 because A and B are interchangeable. So A and B is different from B and A with the same thing. So 6 times 2. That's all the ways I can order the A and the B. But then I have to multiply it by, well, how can I order the rest? Well, it's going to be, there's 3 options for this slot, 2 options, 1 option. So then it's times 3 factorial. Probably confusing first time looking at it. That's okay. I remember when I did this in math, it was tough. It was tough. It was hard to learn. But if you do more problems, this is really a unit where you have to do a ton of practice problems to really get a feel for all the different scenarios. But that's how you do something when they have a restriction where you're separating things. And draw things out, write it out, work it through. But let's just do a textbook problem together, and then I will send you off. Okay? Let's see here. So, in how many ways can 7 books be arranged on a shelf? I have 7 books, and I'm assuming all the books are unique. Okay? How many ways can I arrange the books on a shelf if all the books are different? Okay? Books are different. There's no repeats is what they're telling us. Books are different. So hopefully you've already yelled out the answer to me, and that answer would be 7 factorial. 7 books, there's 7 factorial different ways. That first slot has 7 options. That second slot has 6 options. Third slot, right? Because the order matters. So what happens if 2 of the books are identical? 2 books are identical is another way of saying I have 2 repeats. So in this case, if 2 books are identical, it's 7 factorial divided by 2 factorial, my repeats. I have 2 repeats, 2 factorial on the bottom. I'm not going to solve an answer, you can do that on your calculator. C, the books are different, the books are all different, and the mathematics book must be on an end. So the books are still different. Math must be on end. Okay? On an end. So that means 1, 2, 3, 4, 5, 6, 7. That means that I can have math either here or here. Okay? I have 2 options for the math book. And then, so there's 2 options for the math book. either that's my first scenario, and this is my second scenario. And then just like in the last, so this is kind of like the one where we did with A and B being different places, or more than a space away. Then the rest of the book, have 6 different ways. So I'm going to have one option where I have my math book here, and then I have 6 factorial. But then I have a second option, so that's why I multiply it by 2, where I'm going to have 6 factorial here, and then my math book is going to be on this end. So then I'm going to have like that. So it's 2 times 6 factorial. Okay, and then finally they're going to give me the curveball here. The books are different, and 4 particular books must be together. So now they're saying 4 books must be together. Okay, so we have basically, they're giving us a scenario now where I have 4 books that have to be together, and then I have another 3 books, okay? So I have to treat this as an object. So now I have essentially 4 objects, but this object has 4 factorial ways of being arranged, right? Because the order of these books can also change while we're changing the order that this shows up with the others. So it's 4 factorial, and then if this was an object, if I'm treating this as an object, and these are the other 3 objects, how many ways can I arrange these 4 objects? 4 factorial. So it's 4 factorial times 4 factorial. And that's how many 4 books must be together. And 4 particular books. 4 particular books. These 4 have to be together. But there's 4 factorial ways that we can arrange those 4 books together, and then there's 4 factorial ways that we can arrange back with everything else. It's going to take a little time to get your head wrapped around, but we'll get there. And we're going to take it slow. I think I've given you enough to go and flourish. I hope.